class yesterday, we talked about functions, and we were getting ready to talk about whether or not something, or how to find the domain. Now, back in Algebra 2, you guys talked about domain, and we did a lot of just looking at the graph, being able to talk about the domain. How far left does my graph go? How far right does it go? Are there any breaks in the middle? Now, with this in mind, as we look at example 3 here, we're going to talk about the domain, but we're not going to start with the graph. We are going to look at the graph, but I'm going to save that for the end, because what I want you guys to be able to do with domain is I want you to be able to use all your skills here. Yes, I want you to be able to look at the graph, but there's times we don't have a graph available to look at. So I want you to be able to gather some information looking at just the equation. So if you look back to the top part of your notes from yesterday, find the domain of a function right here. With that in mind, there were two things, or kind of three, that I want to review. Okay, the two things involving the equation. Remember, denominators can never equal 0, so that's something to keep in mind. And the inside of a square root must always be positive, or greater than or equal to 0. So those two pieces is what we're going to check on equations. We're going to check if there's something under the square root that could be negative and would cause a problem. We're going to check if there's something in the denominator that could equal 0 and be a problem. With those two pieces of information, we can figure out our domain. But then we're going to use the graph to help confirm us. Okay, that's what we're going to look at here. So, as we look at example 3, part A, the domain of f of x equals square root of x plus 3. Based on what I just talked about, what do you see that we have to concern ourselves with? What's in this function that I mentioned?
X under the square root.
Okay, we have a square root and it has a variable under it, yes? So, what did it say up above? Whatever's under the square root must be greater than or equal to 0. Okay, it has to be positive. Now, in this case, it's not just an x, but it's an x plus 3. So what I'm going to do is I'm going to take whatever's under that square root, the full expression, and set it greater than or equal to 0. Now, basic solving. What do we know if we solve this for x? Subtract the 3 over, and we know that x must be greater than or equal to negative 3. Okay. I mentioned square roots. The other piece I mentioned denominators. Except, do I have a denominator here? I don't even have a denominator. So there's nothing to worry about denominator-wise. Whatever's under the square root. Basically, to make this problem work, x has to be some number that is negative 3 or larger. Okay? Yes?
So like the x and negative 3, is that say equal or?
Greater than or equal to.
Greater than equal.
Yes. That is a greater than sign thrown in there. Now, this is all we need to know to write our domain. We'll confirm it on the graph here in a moment, but how do we write this in interval notation? Greater than or equal to negative 3?
Bracket negative 3, comma, infinity, bracket, parentheses.
Okay. So, greater than or equal to negative 3 is starting at negative 3, yes? And it's going to the right. Because it says equal to, we're going to do a bracket. Infinities always use parentheses. Now, take a peek at the graph with me. This is where I just grabbed something else. I didn't hit zoom 6. I should have hit zoom 6. There we go. Your graph should look like my graph, yes? Now, does this agree with our answer?
Yes.
What's it look like is happening? it looks like the graph is starting here around -3. Now, and here's something, if I just hit trace, that'll give me a cursor that I can trace over with, and if I go over left, you'll notice I still have a graph here at -2.7, at -2.8. Notice at -3, my cursor, or -3.03, my cursor has disappeared, and I have no y value. My graph doesn't exist past -3. Now, this is where I don't want you just relying on the calculator, though, because I don't want you to tell me that in interval notation it's -2.87 to infinity. The calculator's not going to give you the exact value, which is why we're using the equation here. And we're using that equation to know that, okay, my graph starts at -3, and then what's it doing? It's going off right to infinity. Okay, so that's kind of your, I don't know if I want to say proof, but kind of the backup there. Is that my graph goes from -3 to the right. So, reminder, we're finding domain. We are working in terms of x values when we talk about domain. And then the other piece I have on mine here is this is x values. And when you read your x values, you're going to read x values from left to right. Okay? Again, my recommendation is going to be not just relying on the graph, not just relying on the equation, but I'm going to suggest you do a little bit of both. Because the equation helps me to know to use -3, the graph helps reinforce all of this also. Okay, questions there? Okay, let's try B then. New function. F of x equals square root of x over x squared minus 25. Now, I'm going to say hold off on the equation for a moment. And I'm going to say, okay, I said that wrong. Hold off on the graph for a moment. Let's think about characteristics of this equation. What do you see here, based on what I've said, that we need to think about, that we need to notice and be concerned about? What do you see, Toph?
Square root and fraction.
Okay, so we have a square root again, yes? What do we say about square roots? Whatever's under square root must be greater than or equal to 0. Positive. What's under this square root? Well, this time it's just x, right? So x must be greater than or equal to 0. There's no solving on this one, is there? So I know that part of what's going to have to do with my domain is that x has to be 0 and above. I know that. Okay. Besides square roots, I said to watch for denominators. What do we have in our denominator? We have x squared minus 25. And what can a denominator never equal? 0. So a denominator can never equal 0. Well, this sounds weird, but I'm going to set my denominator equal to 0. And I'm doing that so I can find what values x cannot equal. Okay? So if we solve this, x squared minus 25 equals 0, what's happening? Are you factoring it? You're okay. Can it factor? Yeah, it factors into x and what? 5 and 5, right? It's difference of squares, and what are your signs? plus and minus, right? And I'm perfectly fine with that. That's great. My brain was going a different direction. My brain was solving this a different direction, and I was going to add the 25 over to the other side. And so then I have x squared equals 25, and then what do? I take the square root. And then what do we get when we take the square root?
Plus or minus 5.
Yeah, just remember when you take the square root in an equation setting, it's plus or minus 5. Two different ways to solve the problem, both great. Okay, do whichever one you see. I would say the slight advantage to Angela's is she's going to get both answers for sure, which when you guys take the square root sometimes, what do you sometimes forget? The plus or minus. Okay. Both are good though. Now, let's think about this here. Okay, I haven't looked at the graph yet, but let's think about what we know. Okay, I'm just trying to put this, I'm not trying to graph the graph, just trying to put this information on the number line. We know x has to be greater than or equal to 0, and we also know that x cannot equal -5 and 5, yes? So, we know x cannot equal -5 and 5. Okay, like those values don't exist. X has to be greater than or equal to 0, which means it's going to go 0 to the right. What's the catch here, though? 0 to the right, and then it's going to stop, but then it's going to restart on the other side of -5. So it's everything 0 and above except -5. Okay, or positive. Don't ask. Don't ask why I had 2 -5s on there, because I don't know.
All right.
It's Friday,
Yeah,
right?
it's Friday.
Okay.
Go home. You want me to give mine?
Okay. No. Okay. Are we there with me? 0 to the right, skipping over +5. Because +5 is the only thing that's going to be right of 0, not -5. Okay. Can you write this in interval notation?
No.
Yes, you can.
No.
Okay. Interval notation. Now, and by the way, did this fact that x can't equal -5 end up mattering? It ended up being irrelevant. Okay, because everything had to be 0 and above. Okay, where does my shaded area start? 0. With a parenthesis or bracket. I said greater than or equal to, didn't I? So yes, it is a bracket. 0 to what? 5. 5 with a parenthesis because 5 is not included. Union, because we're going to have more than one answer set. Where does my second piece begin? It begins on the other side of 5 with a parenthesis to pos infinity, which always uses parenthesis. Now, that's me just looking at the equation. Noticing that there's a square root that has to be positive, and noticing that there's a denominator that cannot equal 0. Okay. Did you look at this graph? Did you look at that?
I didn't know.
Okay, it's kind of a funky graph, but here's my question. Does it agree with my answer?
Mm-hmm.
Do you see anything over here to the left? No. And now, here's where, if I hit trace, it always plops you on the y-axis when you hit trace. If I go left, notice what happens. I have no y value, do I? Okay. So right there, that's how I know my graph does not exist below 0. And then once I get over here, notice, okay, I've got y values. We're existing 0, my x value 4.2, 4.39, 4.5. We're good, we're good. It happens to give me exactly 5. Notice what happens at 5. It's gone. I don't know if you guys recognize it or not, but there's a vertical asymptote. Okay, your calculator doesn't show the vertical asymptote, but that's what we know is there. And we'll talk about in lesson 1.2 how we know, or later on in this lesson, how we know it's a vertical asymptote. And then if I keep going, now my cursor is above, yes? And notice I have y values. So this matches up with 0 to 5, and then 5 to infinity. Is it possible to just look at this graph and get that same answer? It is, as long as you understand and know enough. Okay, and that's what we're working on, is getting to that point. Yes?
How do you do a fraction on here again? Can't remember.
Alpha F1. Did you get it? Okay, we good with that one? Okay, let's look at the backside. Okay, continuing a little bit more with domain. A of s equals square root of 3 over 4 s squared. Okay, think of what we've talked about. Think about what you know about this equation. Share your thoughts. Say what now?
I don't know.
Now, okay, before we go too far, one thing I do want to point out, and this will mean a lot in the end. Normally our functions say f of x, yes?
Mm-hmm.
This one says a of s. Okay. For right now, it just changes our variable, doesn't it? Okay. Two things we're looking at. Square roots. Is there a square root issue? I see a square root, but my square root has to be positive. Do I even have a variable under the square root? No, I don't have a variable under the square root. So square root of 3 is just a number. I'm good. Denominator cannot be equal to 0. Do I have a variable in my denominator? No. 4 is just a number, right? So square root of 3 over 4, that's just a coefficient. To be honest, it's going to be our vertical stretch or compression is what it's going to be. Now, what about s squared? No. What's the graph look like? S squared is a parabola, yes? X squared is a parabola, so S squared is a parabola. This graph is a parabola. The square root of 3 over 4 is just the vertical, I think it's a stretch. But this is just a parabola. We don't have any negative square roots to worry about. We don't have any zeros in the denominator to worry about. It's just a parabola. Based on that information, if we're just looking at what this equation is, what would you say the domain is?
Negative infinity, positive.
Okay, a parabola in general is negative infinity and positive infinity, or if I put it in words, I can use the expression all reals. Okay. There's a but though.
Is it negative 4? Because the denominator is 4.
No.
It's
Denominator is just a number. Denominator is just a number. Don't get hooked up, guys. Don't get hung up that there's a denominator and there's a square root when they have nothing to do with the variable. Okay? My only variable is s squared. And it's a parabola, and legitimately, if we're just looking at the equation, this is all real numbers. Now, the catch, if you want to call it that, what is a normally stand for in math in terms of formulas? Area, yes? Okay. So if this is an area formula, what would the variable s stand for within an area formula?
Surface.
No? Side? Okay. So this is not an area formula I expect you to know. But if we're talking about this is the area of some object, don't care what object, with side length s. How does this affect my domain? Domain being the s values. What would have to be true of s, not because of the equation, but just because of reality?
Positive.
S has to be positive because sides of any figure are always positive. Okay? Now, to be honest, this is area of a equilateral triangle with side length s. Did I expect you to know that? No. Okay? But what I'm trying to point out to you here is that this is an area formula with side length s. Okay? Can that affect our domain? Yes. It adjusts our domain not because of what numbers we can legitimately plug in there, but because of what a side length can be. So because of that, I'm going to change my domain to be only positive numbers. Okay? So, but this formula models area of a triangle with side length s. Okay. So key pieces there. We're talking about it being area and side length s. With that in mind, how am I going to restate my domain? My domain no longer starts with negative infinity. What's it start with? 0. 0 to infinity. Infinity uses parentheses. 0. Technically, can you have side length 0? No, because then we've got a triangle that doesn't exist. So we're going to use parentheses, or in other words, s greater than 0. Okay? That's an example of a catch. The formula itself is obviously all real numbers. Okay, I think I got you guys to believe that. Okay, knowing it's a parabola. And this is where also using your knowledge of what the graph looks like is helpful. And if you graph this, you're going to get a parabola. Questions on that one? Okay, one more domain, and then we've got to talk about range real quick. Okay, f of x equals square root of x squared plus 5 all over x. Okay, I'll look at the equation in a moment, but what pieces have we been considering here? What have we been considering?
Square roots and denominators.
Okay, square roots and denominators. What do we know about this square root? Whatever's under a square root must be greater than or equal to 0. Must be positive. There's an x this time, so I need to check this out, don't I? Okay? If we start solving this, well, what am I going to do? Subtract the 5 over. X squared greater than or equal to negative 5. What's our next step? Square root. What's the issue?
Imaginary.
Square root of a negative number is imaginary. Okay, that in my brain says, whoa, red flag, something's not right here. Because we're talking domain. Are we talking imaginary numbers? No. Okay, so that right there, I'm like, okay, I've got to rethink this. Whatever's under a square root has to be positive. Okay, think about what happens when you put a negative number in here for x. What happens when you put any number in here for x? You're going to square it, and when you square any number, it's going to be a positive. What happens when you add 5 to a positive number? It becomes a bigger positive, yes? So, can this specific expression ever be negative? I mean, I could put negative 100 in here, but negative 100 squared is going to become positive. Add 5, you're going to have a bigger positive number. So this is one of those unique places where it's not going to end up mattering. Okay, like this is going to end up not mattering because x squared plus 5 is guaranteed to be positive. X squared plus 25, or plus 5 is guaranteed to be positive, so no effect on domain. Okay? That's what I would say right here. You put a number in and square it, it becomes positive. You add 5, it's still positive. Now, if that was a minus 5, would we have a different story? Yeah, because if you square a number and it's small enough and you subtract 5, it could go negative. This one can't. Okay, but we did our job, right? We investigated the square root. What's the other piece we needed to investigate? Denominator. The denominator cannot equal 0. So my denominator is just x. So if I set it equal to 0, we learn that x cannot equal 0. Okay. What's that going to mean your domain is? The only issue I legitimately end up having is x cannot be 0, yes? So if x cannot be 0, think about it. That's the only issue I have. Where's all the rest of the shading? Which infinity? Okay. There's the positive infinity and there's the negative infinity. Okay. How do I write this in interval notation then? Negative infinity to 0. X can't be 0 though, so we're using parentheses. Union 0 to infinity. Now, again, I want you using these graphs. Have you looked at the graph yet? Probably not, because I didn't really want you to before I started doing this. Okay. If I read my graph left to right, does it agree with the domain we came up with? What's going on here? My graph is going off infinitely left, yes? Okay, now, as I follow it right, follow it right, what happens? It starts to move, as it's continuing right, it starts to move down, yes? Now, if you hit trace, notice what happens when x is 0. Y doesn't exist. So what do you think that y-axis is acting as? It's acting as a vertical asymptote? Okay? And then notice it goes down so far, and then when it hops to the right, it's going to go way up high, but then it's going to work on following off to the right. So what's the only x value that got skipped over is the 0. Okay. So reading left to right, my graph exists off to the left, takes a break at 0, and then it continues on the far side. For domain, I want you guys to be able to use your skills together. It's important to be able to look at an equation and be like, oh, x can't, the denominator can't be 0 there, or my graph has to be positive there because of this square root. But then also being able to look at the calculator and understand what the graph is doing is good too. Okay? Okay, we got to talk range. Now, range is very similar. When we read the graph on domain, we go left to right. How are we going to read the graph for range? Range is no longer x values, range are y values, so now we're going to have to go bottom to top. Okay? You'll notice up here I have it written, same rules apply for range as I do domain, only solve for x first, and then you can also still read the graph, but when you read the graph, you're going to be reading the graph from bottom to top. I'm going to tell you up front, on range, most of the time, I'm going to tell you to read the graph. Plug it in your calculator, try and figure out what's going on bottom to top. If you solve for x first, which we're going to do on this first one, the problem with solving for x first is not always easy to solve for x. It's not always, very doable. So if you solve for x first, though, you can use the same ideas of square roots must be positive and denominators can't be 0. So let's demonstrate on A. First of all, you guys know f of x is the same thing as saying y equals 2 over x. Okay, how do I solve this for x? If you want to get x out of the denominator, we're going to, how do you undo dividing by x? Multiply by x. If I multiply one side by x, multiply the other side by x, x times y is xy. On the right, 2 divided by x times x is 2. The x's cancel. Okay, if I'm trying to solve this for x, what are we going to do? It's x times y. We're going to divide by y. We now have the equation x equals 2 over y. Okay. It's range now, so think in terms of y. What issues do we have with the equation before we look at the graph? Right there, folks. Denominator cannot equal 0, so what do we know? Y cannot be 0. So y cannot be in the range. Do we have any square roots to worry about? No. Okay. So I'm proposing my range is going to be everything except 0. Let's look at it on the calculator. So if I go back and graph the original function, it was 2 over x. Helps if you select the graph. Try this again. There we go. This graph looks similar to the last one, doesn't it? Okay, that's fine. Okay. Read this graph with me. As we read this graph, Okay. Range. Get range in your brains. How low is my graph going? Negative infinity, yes? Okay. Now, as I'm tracing this graph, what's it doing? I'm following, it's getting higher, it's getting higher, it's getting higher, but what's going on here? Okay. Can you see what's happening at the x-axis? There's a horizontal asymptote happening. What's that going to happen? This graph is going to follow underneath the 0, but is it ever going to touch 0? No. And then eventually what happens? It hops to the top side of the axis, and what's it do? It's now going to trace up. And it's going to go up to where? Infinity. What's the spot we skipped? In terms of y values, the only y value we don't hit is 0. Now, I just realized I never wrote the answer, did I? If y is everything but 0, what are we doing? Is it the same answer as last time? Except the last time was domain, but it goes as low as negative infinity, which always uses parentheses, comma. It runs up and along 0. Parentheses or bracket for that 0. Parentheses, it's not going to touch it, and an asymptote. It's not going to touch an asymptote. So parentheses, union, where does it pick back up at? 0 on the positive side, so parentheses, up to positive infinity. Okay. It takes practice. I know it does. Okay. One more to look at. B. How do you feel about solving for x? You've got x squared on top, x squared minus 1 on bottom. Is this going to be an easy solve for x? No. And here's what I'm going to suggest. Domain, I like you looking at the equation a lot first, and then the calculator. Range, more often than not, what am I going to recommend for range? Go straight to the graph. Okay? Most often, I'm going to go straight to the graph. And that's what we're going to do. Okay? Is we're going to go read the graph. Because solving this is not going to be fun. Okay? It's a fun graph, isn't it? For those of you choosing to look at it. So this one, x squared over x squared minus 1?
Yeah.
So I'm trying to save myself. I typed these all in during second hour, so do I need to retype them in again?
Ooh, okay.
Okay. You have a graph there, yes? Okay, start thinking about it. I'm gonna draw a picture here so I have something to kind of point at, so to speak. No, I shouldn't do that. Let's. Okay, guys, you ready? We're in range mode. Y values. How low do we go? Are you with me? There's this upside down parabola, and what are both sides of it doing? It's going down to negative infinity. So what's my range going to start off as? negative infinity, which always uses a parenthesis. Now, okay, we're following this parabola up. We're following up. We're following up. What happens? It stops, yes. Does the rest of my graph immediately pick up? No. Where does it stop at? Yeah, it's the y value of 0, right? Because it's the ordered pair, 0, 0. But what matters of that? The y value. And here's the deal. Remember, if you hit trace, where does it plop you on at for trace? 0, 0, yes? I feel like it's really blurry all of a sudden. I don't know why. But it plops you on at 0, 0. So this is going to go, this piece is going to go up to 0. Parenthesis or bracket. Does it actually touch the y value of 0? It does. That's not an asymptote at 0. That's a point on the graph. You see y equals 0 on the calculator, so we're going to touch. Now, I'm not done. Union. Where does my graph pick up?
One.
He's squinting at the graph and suggesting 1.
I agree.
No one's agreeing or disagreeing, so.
I agree.
You agree there.
I agree.
How do we know it's 1 and not 0?
Because we can't see. Very good. You're right.
I'm just trying to play devil's advocate, honestly.
I see where you're coming from.
Okay.
I agree with
But I mean, here's the thing. What do you think is happening there? Those graphs are going off to the side because there is a horizontal asymptote this time, okay? Now, I'm going to use the calculator to help me. I'm on trace, right? If you trace to the right, it starts off going to the parabola, or you can go to the left. Okay, and then as you watch, just hold down trace and go to the right. Watch your x values. Or not x values, your y values. As I watch my y values, 1.006543, 1.002, 1.001, 1.0008. Okay, what am I trying to get at?
0.
It's not going to touch 0, but it's not even going to get to 1. If that asymptote was at 0, we'd already be at 0 point something. Hold on real quick. So, horizontal asymptote. There's a horizontal asymptote at 1. So my graph picks up at 1 with a parenthesis because it's an asymptote. How high are we going? Positive infinity. Okay, guys, you have 10 homework questions to get done. The 10 homework questions are just single parts. You've got like 4 functions, probably 3 or 4 domain questions, or 2 or 3 range questions. Okay? Practice them before Monday. We'll talk questions, definitely. But practice, use the algebra, use the calculator to help you.